Today we're going to find out what spectator ions do, look at examples of ionic equations that you need to know about, and then finally antacids and an experiment that you can use for your internal assessment. And remember, you can download your very own copy of this PDF, so you can be making notes as we go through. The link is in the description. Okay, so spectator ions. Here is our definition here. So what is the big idea? They don't do very much. They are just there cheering on from the sidelines. But it is quite hard to see from a regular equation. So what we're going to do is we're going to split things up into the ions that make up everything in a aqueous solution. And then from that, it'll be a bit easier to figure out what is going on. So we have some hydrogen. We have sulfate ion. We have 2 sodium ions, and we've got the hydroxide ion, which sort of ends up over here. So from this, what is going on? So hopefully we can see that we have some unchanged ions. So we've got sodium over here and sodium over here. We also have sulfate over here and sulfate over here. So because they haven't done anything, these are called spectator ions. And then what we're left with over here, this is called our net ionic equation. So this is the ionic equation, and then we have our net ionic equation, which is just showing the ions that have reacted. So why do we have these spectator ions? Well, they are here to help balance the charges. So without some extra negatives and positives, then the charges wouldn't balance and you just wouldn't be able to have your solutions at all. So you couldn't just have a beaker of something entirely negative or entirely positive, even if you wanted to. So they are there to balance the charges. Okay, so now let's go through the ionic equations for the acid reactions that you need to know about. So these are all the main reactions. We did these in more detail in another video, and we looked at how we can name salts and all of that sort of stuff. So so if you want to find out about that, then click on the little tab that should have appeared on the screen. So let's go through these nice and quickly. So starting off with an acid and a base. So we'll just be highlighting our different elements or group compound ions again. See what is going on. And then I would always advise doing this at the start if you're feeling really unsure about this, because it does help kind of see what is happening. So we can now see that we've got chloride. The chloride ion is both before and after the arrow, so that must be our spectator ion. And then we finish up by writing our net ionic equation, just showing the changes that are happening. So how do we know what is splitting up into ions? So the things that split up into ions are the aqueous solution. So if it's an aqueous solution, then that is what is getting split up into ions. So so in this case, we've got that splitting up into ions. And we have magnesium splitting up into ions. Nitrate is split up into its ions as well. Okay, let's highlight the rest. Okay, so solids and gases and liquids do not split up into ions. Alright, so from this we can hopefully see that we've got the nitrate is the same before and after. So with this, it looks like the magnesium is the same before and after, but it is not. It is a bit different. So this is magnesium the solid, and this is magnesium the ion. So it has changed. And because it has changed, it features in our net ionic equation. Okay, so on to our last one. So a metal with a metal carbonate. So again, we are just looking at what is aqueous, and it's only the aqueous things that are splitting up into the ions. So hydrogen, chloride, sodium, and carbonate being a bit awkward, but there we go. Alright, so let's see what has changed and what has remained the same. So chlorine is the same and sodium is the same. So then yeah, we can get our net ionic equation written down without those spectator ions. So yeah, so with the net ionic equations, we can see that yeah, this one doesn't have any metals in. This one's looking a lot more simple and basic. And then yeah, again, this is very simple. And then the neutralization one is the most simple. So yeah, you will start to see that the net ionic equations do look very, very similar, if not identical, because yeah, you're kind of getting rid of all the things that don't react. Okay, now finally on to antacids. So yeah, so an antacid is a medicine that you can take when you have heartburn or any related issues from having too much hydrochloric acid in your stomach. And yeah, the main active ingredients are weak bases, and what happens is they neutralize some of the hydrochloric acid in your stomach to alleviate your symptoms. Happy days. And this reaction is great news for you guys, as you can utilize it by planning an experiment around it for you to use in your internal assessment. So let's have a look at how you can do that. So yeah, the main aim of the experiment is to find out how effective different brands are, and you can write a hypothesis around that. So you would get one tablet and you would put it into a volumetric flask. You would then react it with some strong acid, and this is to fully neutralize your weak base. And if you know how many moles you started off with, you can do a titration to figure out how many moles reacted with the base. So you would take a sample from your volumetric flask, then you would have acid over here, and then an alkali over here. You would do the titration, and then once you know how many moles of alkali reacted with this, you can then figure out how many moles of acid were left over here, and then from that you can figure out how many moles of the tablet you had. So it is a back titration. I go through back titrations in a lot more detail, kind of going through all the steps of the calculation in another video. So the link for that will be in the description, and also it will be at the end of this video to click on as well. Okay, so that is all from me. Thank you as always for watching, and if you have enjoyed the content and you want to support the channel, then please do like and subscribe, and tell all of your chemistry friends about it as well. All right, catch you in the next one.